Hello, everyone, and welcome to our new episode of All Things Tech. And today we have a special guest, Olivier Bloch. Hello, Olivier.
Hi there.
Yes, so really happy to have you with us on this episode. And maybe we can start with right away with the questions. So, Olivier,
Sure.
who are you?
Hey, well, first of all, thanks for having me on your podcast. I'm thrilled to be here, and I really mean it because and as we'll talk about today, I'm passionate about communities and community building, and also engaging in interesting conversations. So who I am, I'm an engineer. Who happens to have spent lots of time. People certainly know me through that at Microsoft, evangelizing for IoT technologies. I also used to be an embedded real-time developer prior to that. And I'm French living in the US. That's me at a high level and passionate about Internet of Things, embedded development in general, technology in general.
Wow, awesome. And just a follow-up question, obviously, since you're a guest on the show this time, so you're not leading. What's the one thing that actually most of people don't know about you? I mean, you already have done hundreds of episodes, but what's the one thing that you never said actually online?
And that's interesting you asking that because I always thought it was super transparent that people know everything about me. But I don't know. In a nutshell, I'm French. I was born in Salvador from my French parents. My parents were a bit crazy, so we're traveling a lot around the world. I lived in Indonesia in a small village for 3 years. I lived in Italy for 4 years, and I speak Italian as well. I have 3 kids. I'm 47. My older kid is already 18. She's voting. And
Wow.
yeah, and these are the few anecdotes. I love skiing. I love one wheeling, and IoT. Again, people know that.
Well, we're in the same boat. I also have 3 kids, and the other one is now 18. So I feel your pain, brother. Believe me.
Parenting is hard.
Yeah, everything else is easy. Shabazz, any
Hi,
interesting
Rico. Hi,
questions from
Olivier.
us? Hey?
Yeah, no, it's interesting to hear that you were doing embedded development before, because that's quite. I find sometimes some people always just want to concentrate on the embedded development and find it harder to transition to the whole IoT networking and the cloud work that's associated with IoT. All of those extra skills. How did you manage to make that transition?
Well, the transition has been actually thanks to Microsoft. So I used to be that embedded developer in the working for some customers, building telematic solutions for a car manufacturer in France, building real-time franking solutions. So there's machines that will put a stamp on an envelope, like 3 envelopes a second, and so on. I was developing real-time systems for that. And I specialized in Microsoft embedded solutions, Windows CE in particular, and being an expert and one of the few experts in Europe. Came the time around 2006 where Microsoft was looking for developer evangelists for that growing market of embedded and smart devices. What they wanted to be smart devices. And so they hired me to be a developer evangelist. And I was like, never talked in public. And I got to the interview. Remember that, my now friend, Eric Mitlet, was interviewing for that position. And I got the job because it was the only one not coming was a tie. And
No.
and all the other ones, was friends like beginning
Okay.
of 2000s, and you do a business interview, whatever type of job, you come with a tie and suit, right? And I was wearing nice pants, but no tie. And that got me the job. That was the anecdote. And then I learned lots of skills about communication, about marketing as well, but always staying as close as possible to the developers, coding myself, not just for demos, but also for products, and evolved within the company with that hat and different other ones. We can talk about that later on. But so I I basically like to learn new things. And so the challenge was interesting. I jumped on it. They gave me my chance, and I evolved from there.
Oh, that's an interesting path. So you definitely have been involved in so many Internet of Things projects in different verticals and different industries, as you said, from envelopes to everything else. So what are the most common challenges that actually you have seen and you have encountered within the IoT product development, and how do you actually approach them?
Yeah. So, and that's interesting. I think my background as an embedded developer led me to understand better that perspective. But to me, IoT and the technology going around, edge compute and others, they are at the intersection of different domains of expertise. And you need to have different types of engineers and sometimes non-engineer people work together to make these projects exist. And you need to have a hardware engineer, you need to have electronics engineer, you need to have someone who is a software engineer for embedded devices, another one who is an IT pro, and then you have a software engineer for other types of application. And then you need to have eventually an electrical and or a mechanical engineer, because the solution is part of some mechanics of some machine. And so you now need to have different types of people interacting and working together on the same project with vocabulary that is different, with perspectives that are different. And that makes it super challenging to put everything together, because everyone is convinced that their domain is the most important. A
Yes.
good example of that is very simple. If you want to put temperature sensor into one of these industrial ovens that are meant to melt metals, that's something that is critical. The hardware part is super critical. Thinking about all the wiring, thinking about the impact of the overall temperature around that oven onto the hardware, as well as taking that into account into the software through, the data is coming from this oven, and you need to take into account the conditions that are out there to adjust that level of temperature, and so on and so on and so on. Like, this is just an example. You can imagine how complex something as simple as probing temperature into a harsh environment like that can become. And this is actually super critical, because that measure of temperature is something that will help having the right temperature and getting to that right temperature, the right speed, so that the metal you're melting gets the resistance or whatever capabilities or features you want it to have. And so, like, it involves chemistry, it involves physics, it involves software, like all of that, right?
Yes.
And this is just an example of like so many. Like farming, same thing. The farmers knows the soil. Is it the engineers who's going to put the probe that will tell the farmer, hey, what kind of humidity it will need to be? Is it always the same? No. Like, you need to talk to that farmer for him to tell you, no, I want to measure, that air, and my threshold will be different depending on the season, depending on the part of my fields that we are measuring that from, etc. And so that's, to me, one of the main challenges, is making all of these people understand each other. And that's critical to me.
Well, think how challenging is the role of a CTO of an IoT company, because he's chartered to make all these relations and also to work with the product people, with the marketing, with everyone else.
Yeah.
It becomes a
Yes.
matrix.
And you need to have that person who has the big picture,
Yes.
that includes the business part of it, the value out of it, right? So you have some very cool projects you can build with devices and sensors, super cool, turns an LED on and blah, blah, blah. If it has no value for the business it's developed in, then it's like everything else. There's no reason to invest in developing that if there's no return on that investment. And you need to have someone that is able, or someone's or are able to determine that value, understand it, eventually even like detect it in something that might look like just fancy, and that's requires skills and experience that not many people have, because it requires understanding all of these people, not being an expert in all of that,
Yes.
but speaking a language that everyone understands, basically.
So you have developed these skills over the past 10, 15, 20 years?
I
What?
over the last 20 something, even more, right?
Wow,
So
okay.
24, almost 25 years, gosh, doesn't make us younger. So 25 years, I didn't grow a beard, but I could. I did build some of these skills. I think I was lucky enough so that I could see different parts, in depth, different parts of the entire business, and I evolved with it. There was a pivot time in my career within Microsoft when I chose to stop doing embedded and go do open source and open standards with a subsidiary called Microsoft OpenTech. And did that for 3 or 4 years. We created a subsidiary. I was part of the first, employees of that subsidiary, and the goal was to pave the way for Microsoft to do open source. That was totally new to me. I was the embedded guy, Windows embedded guy, an expert there, developer evangelist, and then suddenly I'm asked, "Hey, do you want to do that? Subsidiary to do open source?" I was like, "Yeah, it's interesting." And I evangelized for open source at Microsoft, within Microsoft, and outside. And I built a different type of skill set that I'm still using today, and I believe is important in the work of community, which is using GitHub and understanding what it means, using code that is coming from the outside and understanding what the licensing is about, understanding the interaction between open source and open standards, how you can develop an open source project and share with the world to influence the definition of open standards or industry standards. And then after that second pivot, we were done with that subsidiary in the form that of like, hey, Microsoft can do open source now. We know how to do that properly and really contribute to the community. And then I had to decide, do I want to do IoT in the realm of device? I wanted to go back to the IoT stuff. Even within MS OpenTech, I created the project called Connect the Dots that meant to be this kind of like, hey, here's how you can put together hardware and cloud and so on. It was like a pretty fun project. And so at the end of MS OpenTech, I had to decide, do I want to go with the Windows embedded group, do IoT on the device side of things, or do I want to join that new team that Sam George at Microsoft was creating called Azure IoT? And I joined the Azure IoT team because I knew nothing about cloud. And I joined because I knew nothing. And I was like, I know that embedded stuff. How can I bring that understanding of what devices are about so that my colleagues working on cloud services don't mess it up and that they understand what embedded devices, real-time, whatever means, connectivity for these devices, security for these devices means, so that they don't mess up Azure IoT. And so that was super interesting. We're 25 devs and PMs when I joined the org. And so that was really at the beginning, and I was in charge of the device SDKs, so connecting devices to Azure IoT. I was looking after the specs for the SDKs in various languages. And so, language doesn't matter to me because, at that time I was in charge of like all of them, JavaScript, C, .NET. And that's pretty fun times. But that was another pivot, which is going to a place where I didn't know anything, bringing my knowledge to enrich that new domain and learning that new domain. That's the background here.
Okay, so you have been founder twice inside Microsoft, once with the open source and then the second time
I
Azure
participated.
IoT.
Yeah, I participated with some of the first in these two inceptions, and that was a fantastic experience for both. Yes.
I can vote. That's the best, because you go and you change this gigantic company and you change how the people are consuming products, how everything is developed. This is the best someone can actually experience. And actually, how did Sam interview you? Did you wear a tie or it was t-shirt or?
Oh, internally. So
how did they decide that you're the right guy, the guy with the small devices, so then he needs to join this 25 people, very small group to build Azure IoT?
I think I would have to ask Sam what impression I made, but it was not, it seems like it has not been a no-brainer, as in I had this mix of culture. I had spent enough time at Microsoft to understand the company and how it was working, as well as my background in the embedded space. And I believe that my experience with open source was helpful as well. All our SDKs are open source. All these SDKs that I was in charge of were open source. And so my understanding of GitHub and so on allowed me to really work well with our dev teams. And I was teaching them. I was telling them, no, you have to do that pull request on the public branch, not on a private branch. Otherwise, it's not open source. It's not
Yes.
the way you do it. And so that was great. And actually, our SDKs have been developed in the open since then, and they are reach for that. And they have been re-architectured a couple times for some of them, because at some point the community was like, hey guys, this is not working for us, and here is where you should change that and that. And we just like, okay, let's scrap that and redo it the way the community is telling us to do it, because they are the experts there.
Okay, amazing. I didn't knew that. I spent almost 4 years at Microsoft, and I was missing completely all that context that you actually gave me around how Azure IoT started, all this transitioning to open source and open source SDKs. So basically, you have built the first internal community in such a sense around IoT.
In a way,
Okay.
that's and that's something that I always strongly believed in, which is especially in the realm of engineering, communities are key. You need to talk to your peers to learn more, to evolve, to share your own tips and tricks, because we all are doing experiments of our own, experiencing things in our own way, because that's the way engineer minds work, right? We do
Yes.
experiments, right? It works, it doesn't work, you learn like that. But we don't have the time to do all the experiments everywhere. And so sharing with others, to me, is key, because you learn from others, you share your own knowledge to enrich the others. And that's what communities are about. And engineering cannot leave without that. I believe strongly that communities are key to engineering and to the inceptions of new idea, to development of innovation, and so on.
What I really liked about your IoT show, which probably people want to hear about as well, but it was exactly that. You kind of got this. It was nice to be able to see you talking to real engineers, real developers, and be able to actually almost like peek over their shoulder as they're coding, so you can actually see what's going on in the CLI or the user interface, and you learn a lot that way. Just picking up little things about how developers are doing things.
Yeah,
From
totally.
that,
I think
yeah.
the IoT show came to be because I found that it was hard to share all that information about so many technologies getting together to so many diverse type of engineers and developers in a simple way. Documentation, too complex, too deep dive. Yes, super useful, and you need it. It's super complete, all the reference documentation, great, and so on. But we needed to have some content that was more about the wow factor, as well as the very rapid understanding of how is this going to solve my problems. I have key problems. What is it that's going to solve my problems? And something that I was trying to do with the IoT show was to have an engineering conversation, engineer to engineer. I was asking question as an engineer, as if I were the one listening, to someone presenting something, right? And we were trying to be at the same time, technically deep, but at the same time keeping things in a format that would be understood by a broader range of types of engineers. I wanted to make sure that when I'm talking about digital twins, for example, that someone doing embedded development would understand what the thing is about and why they should care. Why was it important for them to pay attention for 10 minutes about this video? Because it would tell them what their device would be contributing to, basically. And so that was the overall idea around all of that. I wanted to make sure that everyone could understand complex topics, even if that was not core to their domain.
You made it really inclusive then. I mean, obviously, I have not noticed all these small details in regards to the community that you're sharing now with us. And you have actually built and led several very successful developer communities around, as you said, software, open source, SDKs, IoT topics. What are actually the key factors that are making a developer community thrive?
From my perspective, so thanks for saying they're successful.
They are.
There's a couple of things that I always wanted to, and some of my colleagues, like lately, Benjamin Cabet was a real champion in the world of open source. especially in the embedded open source world. So we worked together for almost 4 years, and he really helped me stay in that realm of reality and stay away from vanity metrics and the things that you would think make or are the signs of a successful community. Personally, I don't think a community is successful because it's big. That's to start with. It's not because you have millions of people around this topic or whatnot that it's working. What's important is that you have an engagement, is that people feel that they can, in a safe space, share their ideas, share their perspective on things, and that you can enrich yourself and learn from others. And so the engagement to me is again, as a matter of fact, IoT Show and other ones have been learning processes, and sometimes we're successful, sometimes not. And it's super hard to understand why some episodes, some blogs, some pieces of content, some sessions at an event are more successful than another. The one thing that I noticed with the technical audience that I know of is that they like to relate to the topic. They like to understand how that's going to help them in real life. And so sometimes you talk about a topic that's going to help like 25 people across the planet. And you know what? To me, this is worth the time. You spend time at creating content for these 25 people. If that helps them, it's worth it. It's not because you're not helping the masses with that specific topic, you should not do it. And that's one of the things that have been motivating me in creating content and picking the topics. IoT Show, like 350 something episodes over, I don't know, you told me actually that, I think
5 years.
More than 5 years.
I didn't realize it was that long. I think we touched maybe the tip of the iceberg of IoT. Just the tip of it. There's so much to cover that they can't. But each time we're trying to make sure that we had clear key takeaways, clear call to action, so that one watching an episode could follow up doing something. Go try that technology and solution. Go read on GitHub. Go provide feedback. Very simple, straightforward, few takeaways, call to action, go there. In terms of measuring the success, it's quality rather than quantity that I always wanted to bring up. And I can tell you, this is always just like challenging. Hey, what are your numbers? And how good is your thing doing? And you're just like, to me, it's been great. I had great chats with that person and I had 2 great comments. And then some people are looking you weird, like, yeah, 2 comments, you're happy with that? I'm just like, yeah, they're the right comments with the right discussion, the right conversation happening. Did I cover everything? No. Did I address everything that anyone would be interested in? No. Did I have that one conversation with that interesting person that would help another one? Yes. And that's my perspective. The other one is making sure people could contribute. So in addition to the IoT Show, I did create an IoT blog on the Microsoft Tech community where in the last couple of years, I invited the community to come and contribute to. And even if it was a Microsoft property, it was super important to me that our partners or MVPs were able to also tell their own story and in their own way with no filter from anyone. And so we did that, and that was pretty well received by them first. They appreciate it. And by the community in general, because we were seeing these engagements, and now it was an engagement from the community with the community, not from a big company with their customers. And that was to me super interesting to see the dynamics of all of that, the excitement around it. But once again, not big numbers, not a huge amount of people, a small community, very engaged, vibrant, and very positive as well. I've never seen anyone really complaining. People were just like, hey, Olivier, I don't agree with you there. Like, okay, let's chat about it. Maybe I'm wrong. And I was wrong many of the times. But having this quality conversation and engagement, to me, is what you should aim at when it comes to community engagement. You should not aim at the big, huge numbers. I don't think that's my personal perspective.
Plus a lot of stuff is slow burning stuff. Like, you don't know. I mean, maybe 3-4 years later, somebody's still looking at one article or one video and gaining information from that. Things can change in the user interface slightly, but that doesn't distract really from the information there. So
Totally.
I agree.
Yeah, totally agree with that. And we're trying as much as possible in the videos to keep everything real, right? There's nothing that is like faked or whatever. Yes, sometimes we have a video demo instead of an actual demo. Sometimes because you work on products that are not public, that are not working yet, right? You have to show something and that thing doesn't work. And you're just like, we're going to screenshot here because, and sometimes you have like live failing demos we didn't cut in post-production because you know what? Fix it.
That's life, yeah.
And that's fine. That's life. And so it's it's really this kind of things that to me bring value to a community. It's the fact that it's real, it's there. The fact, as you were saying, that they can go back to it later as a reference, that's great. And so that's the objective. Helping people, helping that community, solving their problems when they face them is what the community is about.
Yeah, with the lifespan of IoT technologies of 20 plus years, there will be kids in 2040 actually watching your shows.
Maybe.
And trying to figure it out why this factory works like that. I mean, what's this SDK?
Maybe, and I hope they will still be relevant. I believe they will. Believe they will. Yeah. Technology will have evolved, and actually that leads me to that point about IoT in general, which is IoT is here to stay. IoT is a technology that has been growing and developing. Started as a buzzword, and now is something which to me is as critical in the industry, in all the industries, as the wiring for electricity or the plumbing in your house is. It's there. It makes things, it facilitates, it makes things work. You should not see it. It should be safe and working. And to me, IoT is exactly at the same level as your plumbing and electricity in your house and in a smart building or whatnot. It's like it has to be there. Whatever name it's going to take in the future doesn't matter. That technology is mainstream. There's no solution today, or very few solutions, that don't rely at some point on the data that sensors can deliver in an environment, or on actuators that will allow you to control a machine, control an environment, control the thermostat or whatnot. And that to me is really a nice checkbox. Is like, this technology is matured. Yes. And we can talk about, the chasm and where things are at and so on. To me, the fact that we're seeing big companies like Google, IBM, and others were saying, hey, we are shutting down our core IoT service team, it's not because they're dropping IoT, it's because they don't need to have a specialized team anymore. Because the technology, the industry standards, everything is getting to a point where they don't need to invest particularly in there. That's part of their general COGS and general investments. They have to have these capabilities. They will deliver them in a way or another. And the customers will be able to use their services in the context of what today we call IoT apps, that tomorrow we'll call differently, right? It could be, operators applications, could be modern applications that span across not just cloud or a mobile app, but now will span across your infrastructure on premises, your machines, your smart building, etc.
No, I'm with you, especially around all the news around GCP shutting down the IoT. And then you see that if you read the details, it's just they're stopping doing the IoT core, so the hard things like device management, OTAs, all these very hard elements, but they're keeping the GCP pub-subs, so now they're pumping even more IoT device data on top of Google Cloud, which is how they measure success. So I'm with you. Everyone needs to read the details. And back to the IoT show, actually, how it started.
How it started. So that's, I'm trying to rewind now, right? Because now you made me feel old, telling me it was 5 years. So interestingly, I was driving, these SDKs for the Azure IoT team, and prior to that, I've been a developer evangelist for the Microsoft Friends Sub, and so speaking at public events, and so that's something I always like to do, right? Engaging with developers. And to me, as a PM as a program manager for the SDKs, my customer were developers. My end goal was to make sure that they had the right tools for them to connect the devices to the Azure cloud. And one way of doing that was to have proper documentation. So it was like working with our docs teams and so on, and engineers and PMs to have the proper documentation. But then at some point, I was like, I would love to have something that is clearer for my developers to understand why they should use that versus something else, or what value it will bring to them. And I went around and found that IoT Show thingy that had been, used but dead for some time. That I don't recall who was leading that. I was an evangelist at Microsoft. I definitely need to. Oh, Clint. It was Clint.
Okay.
And Clint was driving that thing. It was, and I think it started around demos for keynotes, build, and things like that. And he had like some cool gizmos with like chairs that were on wheels or not. I don't recall exactly, but he had some cool videos there. But he didn't continue because he was onto something else. And I was like, hey, that's an interesting thing, this IoT show. Maybe I can pick it up. And I had never done videos or whatever. So I reached out to Channel 9 at the time that owned that.
Okay.
And so I reached out to the guy from Channel 9 and was like, hey, I would like to revive that thing and have some content about IoT. And they were just like, okay, cool. We just need to have a host. And I was like, and they were just like, you want to do that? I was like, why not? And never did, video hosting or whatever. And we did some shots to try some pilots. They loved it. And then we went on and it started. And from there on, we've been collecting interesting content and recording with the help of the Channel 9 studio, now called DevRel Studios. Great people to work with, and they made it super easy. They taught me a lot about video editing, video processing. We switched to StreamYard during the pandemic to be able to continue delivering these videos even remotely, with all the challenges you can imagine when it comes to demonstrating embedded stuff with connectivity and so on. So it's easier when you're in the same room with the actual device than remotely, but super interesting to do this kind of thing. So yeah, that's the inception of the thing.
Okay. I mean, you're definitely a game changer. So that's also our first video episode. And I'm also wearing my old t-shirt because I never was expecting that we're going to do it on video today. But you've been like so passionate around the video, and in our discussion before starting the recording, that we said, okay, we are doing it on video. And next time also, Shabazz, probably we need a camera for you. So
we need to fix the camera, Shabazz. Yes.
Yes.
And actually, interestingly, one of the reasons I brought up, and I'm super glad that you received that, because it demonstrates you're smart and want to learn and evolve and so on. There's a lot to say about growth mindset here, but I want to get into that topic. But I believe that we need to, as community servants, I would say, want to contribute. We need to understand that not everyone consumes content the same way. And so people listen to podcasts, others prefer watching a video and seeing people talking. I'm one of them. I can listen to podcasts, but I prefer watching someone talking to me rather than just listening to them. It's a different thing to me. People like to read. So it's like all these different ways of consuming the information. So we ought to deliver as many formats to something so that more people can access that information that will help them.
True. Shabazz?
And it's interesting. Sorry, okay.
No, go on.
I was gonna say, it's interesting what you mentioned about how you started the show, because the documentation was not clear, and I find the same thing. The documentation has to be formal often, and it's much harder to. I mean, some like microprocessors, thousands of pages, 8,000 page PDF, for example, and who's going to go through that? And so yeah, blogs, videos, and now podcasts. All of these things can help. Get that information.
And I think documentation, and you look at the different types of documentation that we have in the realm of IoT and embedded and cloud. Well, first you have different formats, because each of the entities were creating these documentation, they don't have the same approach. You go to a website like the STMicro one, they have documentation that is like data sheets for the hardware, right? And so an engineer working on hardware will understand them perfectly. You look at Microsoft, Amazon, all these like software companies, they build the documentation for cloud services, and it's very rich. I mean, like at the end of the day, but if you're not in the realm of software development or network development or whatnot, it's hard to find what you're looking for. And even with like search engine optimization and so on, I always found that searching documentation was efficient when you knew what you were looking for. And so it was not about how do I solve my problem, it's what is the implementation to solve the problem. But if you don't know where to start in terms of the implementation of your solution, because you don't know how to even formulate the problem you're having, then that doesn't work. So you need to be inspired by content that will bring up the problem. You will relate to that problem, and now you will be pointed to, here is a technology, here is a solution that's going to help you solve that problem. And now you can get started. And very often, by the way, if you notice, lots of our IoT Show episodes were pointing to resources in Docs or in GitHub. Go look at the sample, go try it out. Now that you know where to start, you can go there and you will find everything you need in there. So we didn't need to be super thorough in describing and going in depth into everything, because the content is there. It's just hard to find when you don't know what you're looking for.
And there is way too much content sometimes, and it's repetitive. I'm with you. Which are your favorite episodes from the show? Like, do you have some top of mind that you really loved and you use often to point people to watch them?
When you asked me the question when we were preparing for the podcast, and I was trying to think about some to bring as example. But here's the thing. I actually appreciated, and I know it's really lame to say, but I really appreciated most of them, right? There's some that were a bit boring as a host, as in like struggling at making that person answer in a way that would be understandable by everyone, trying to translate and so on. Sometimes it's hard, but for most of them, and I know it's super hard to be on camera and so on when you're not used. So I always, gave a lot of credit to anyone coming on the show for being there, just for being there. But I think the ones I preferred were the ones where we're in situations when we're at an event, for example, going through the booth, asking developers about their demo, what they're showing, and so on. The in-person was the thing I really appreciated the most. Studio work is fun because you work with really fun and interesting people and so on. But being on site, being interacting, standing, and so on, these were my favorite ones. We did a series for the Build event a few years ago before pandemic that I really enjoyed most of any hour. Like, we're talking in front of a big farm truck and then going on to another demo for something else. And it was like jumping from one to the other, like playing with the HoloLens, showcasing some IoT sensor data in 3D in augmented reality, being there and being present mobile. These were my favorite episodes, for sure. If I were to point to episodes, I wouldn't know where to start, because like there's so many topics, so many different aspects that it's super hard. Go for the shortest ones. As you can see, I talk a lot, but some of these episodes were longer than I would love to have, because I know people's attention span is short. But we always said, hey, if the conversation is interesting, we'll let it go, and that's fine. And so yeah.
There's always that speed thing anyway, where you can speed the video up.
You can speed. Listen, the problem for people watching them is I do speak fast, and so if they go to 175 or by 2, they won't understand a word I'm saying. But that's fine.
Yeah, we can go now 3 hours, so we don't have any limit. I mean, I don't have any limit in the evening. We have enough storage to store the video, so we are keeping this episode rolling.
Nice, love it.
So you've got a lot of experience, and obviously you've got all these 5 years of running the show and running communities for I don't know how many years now. We don't want to say again. But what's your actually advice for someone who wants to build or like start a new developers community today? I mean, there are so many new topics.
So the first one, and that's learnings from these years of experience, and that's my perspective. I think we all have different approaches to community engagement and building and so on. Mine is don't try and go for personal fame. That's not the way to go. Try and be careful. You need to measure your success, right? You need to understand where you're putting your efforts and the impact you're having, and you need to decide what kind of impact you want to have. I personally went for quality and helping, even if it's the few, helping people solve their problems, helping them understand a technology, a domain that I'm passionate about, sharing that passion with them and showing them the value it can have for them. And that was my approach for all of them. But you still need to understand and measure the success you're having or not, right? Because you have an objective. If you don't reach that objective, then you're just wasting your time, right? And that's not saying that you're not doing it right. That means that
Yes.
it is something you need to adapt because you're not reaching your objective. If your objective is to have 10,000 viewers after 6 months, then measure things and do the things that will lead you to these 10,000 views, if that's what you're looking for. If you think that you need to help people, well, like measure the engagement and make sure that the questions and conversation are happening, are always answered, and that there's a follow-up, that people know to come here to have an actual answer to their very complex problem. So try and be careful to how you measure the success and the impact you're having. And one big rule: stay away from freaking vanity metrics. The things that make you look good, as in, whoa, I have that many impressions. Like,
Yes.
cool, but your video is 20 minutes and people have looked 3 seconds of it. Yay, that counts as an impression, but no, that doesn't mean you were successful. Unless that's what you're trying to do, right? If that's your objective and don't care about the fact that people are actually watching your video and the content in there, then okay. If you want people to go through it, then what you need to measure is that, and then you need to look at what worked and what didn't. I mean, it's very engineering driven, data driven. That episode worked really well. Why? Well, sometimes you will never know why, but it did.
Yes.
And sometimes you say, hey, that episode, everyone dropped after that. And then you go back to the episode and you say, oh, I see why. I started talking about security. That actually killed everyone. And this is just a joke, because it's super important to talk about security. But at the end of the day, you need to measure, the impact from the get-go. Decide what kind of metrics you're going to implement, and measure success and adapt. And accept that your choices might be wrong. You might be doing things, with a goal and doing the wrong thing for that goal. And so measure the impact, measure how it's working in order to correct, fail fast, correct. And people will appreciate that to a point you can't imagine. They will forgive you for a crappy episode because the next time you're not doing the same mistake and you're not doing, the same whatever. And so it's something that I would always recommend. Be clear on your goal, implement, try, measure, correct until you get to that goal.
Yeah, I think also, like, in terms of impact, there are some companies I know, like for example the Raspberry Pi group. They reckon that they're saving, I can't remember the exact number, but it was either 1 million or 3 million. It must be higher now, every year, just because their customers' problems are being solved in other ways, through the community forums, blogs, all of that kind of stuff. So they're saving huge costs there.
I'm sure, I'm convinced of that, and I like to believe that the IoT Show, the IoT blog, helps Microsoft also. I don't know if it's about saving costs, but it's about having people understand technologies and use them in the right way, and rapidly adopt them, because they are actually when they are solving their actual problems. The other thing that I've been using the community for is getting feedback, getting insights. Getting an actual user to tell us that thing doesn't work, that thing is really bad, why are you doing that? And this is something that you can do through studies and user groups and this kind of things. But to me, there is something to say about how more natural and open people are on forums, rather than in driven studies where you pick people and you're asking them, and it's very biased. And yes, you extract interesting information from this kind of things, but going public, going to the community, they are not nice with you, especially when you're a big company like Microsoft. They're not nice with you. Like the MVPs, the Microsoft Most Valuable Professionals, which is a title you get for 1 year of contributions that accrue to community and content creation for Microsoft technologies. Well, these MVPs, I can tell you, they're not soft with us, and that's great because they tell us what works for them, what doesn't, which is critical for us, because for big companies, because you need to create a tool the way they will use it, not the way you think they will use it or need it. And so listening to what's going on, and also involving engineers. I was always, when I was getting a question online on the blog, on an IoT Show episode, always involving the devs and the PMs and telling them, hey, I got this question, I looked around, I don't have the answer, can you help me? And at the very beginning, some of them were just like giving me an answer and expecting me to deliver the answer. And I was like, go and answer. That's your product. You own it. Someone's telling you that something doesn't work for them, listen to them. And that actually internally was really well received. And
I can imagine engineers need a push sometimes.
Yeah, and the community is not just the developers using our stuff, right? The community is us, is the ones producing the tools as well, as much actually as the ones using it when it comes to developer communities. And you know what? They're developers as well, right? Even if they're PMs, their customers are developers, and so they have to be in that conversation. And this is another aspect of community building, where at least in the ones I've been building, one of the objectives was internal feedback and making sure that our products, our tools, our SDKs were always aligned, or as much as possible, with the users, not just with the scenarios or the features. It's not, if you develop a feature in your service and you put that in your SDK and no one uses it, that's telling you something. That's telling you whether it's unusable because the SDKs or docs or whatever is not good, or that no one really asked for it at the beginning.
Yes.
Right? So many times. And so I got these conversations with the community, with developers. They were telling me, Olivier, you should tell your guys down there that we don't need that. We'd rather them focus on this because this thing is not working for us. And this thing we don't need today. So it's great that you're thinking about tomorrow. Perfect. Fix my problem today. And that actually resonated really well internally.
What are like some of the most interesting APIs or tools that you think are useful for IoT or for developers? So even developer tools. Which kind of things are like any emerging tools or technologies do you think could be interesting?
And I think this is because I'm a geek and like to play around with things. I think systematically having a way to first go from, I'm interested in that, I want to try it, to having an actual proof of concept that works. Like first, I think in all types of technologies, having the toy that you can go and experience for yourself is the best, right?
Yes.
Watching a video is great, but then having that next step, which is, let me play around with it and let's test it. Let's really, see what it can do to me. And so when developing dev kits or samples for specific hardware to explain to developers how to use this or that, to me, it's always been super important to be able to have something that works rapidly, but also something that developers and users could adapt to their own needs. If you like in IoT, it's typical, the blinking LED, as we call that Blinky. That's the typical project. That's the hello world of IoT, right? And it's great because it demonstrates how from software you will activate something on the hardware, right? Or how you measure temperature from a sensor into your device. And now we're talking about connecting that to the cloud. So you see the data in the cloud and you can send a command to turn the LED on. So that's good. First experience, CTO is excited. He goes to his dev team. I want that. And people are looking at that. It's like, okay, you're telling me I need to put that LED thingy with a Raspberry Pi to control my robot arm? It's going to be a bit more complicated than that. But how do you go from that proof of concept to, let me actually extend that proof of concept with the blinking LED to something I can use. Can I, get the information about that specific acts on my robot arm, in terms of, speed and whatever? And if yes, oh, okay, I can see the real-time data there. Now, can I act on that? Can I trigger a workflow and say, hey, I'm detecting that resistance on that one is actually augmenting because I need to use more voltage to get to the same angle than I used to, or I see a trend a long time, and now I extract that insight, and I'm able to say, hey, I want to indicate that this angle, this rotation part here is about to fail. And now, starting from that proof of concept, I can extract value as a user. I can see how the blinky thing or the just reading a sensor information can help me. But to translate from blinky or temperature reading into an actual scenario is complicated, and you cannot address all of them. But you need to make sure that the dev kit, the software, the sample, mostly open source, please, are such that someone can take them and adapt them to their own needs. And to me, that's something which is critical, is the approach to samples, to dev kits, has to be something that should be adapted to the scenario of the user,
Yeah.
because they don't care about the blinky LED. The CTO will be excited about that, but they will care about how can I use that I was told I need to use now that my CTO saw that, and that is magic, and he was able to do that in 2 hours, if not less. How can I tell him, hey, it's going to take me 2 months to implement something, using that technology? Well, it should not take you 2 months. You should be rapidly able to show the value. If not, that means that your sample is useless, the technology is not working as expected, and so on. So I don't know if that answered your question, Shabazz, but I think that's my general, perspective on this kind of things when it comes to the tools.
Yeah,
What is it that really stands out to me? To me, it's like a good way to go from a wow factor, a proof of concept, to an actual demonstration of the value of that technology.
Yeah, that's really good. I mean, yeah, that resonates really well with me as well. And sometimes I find it really difficult where you want to try and use a particular technology, maybe a microcontroller, something like that, and then you realize that they're using development tools with, I don't know, a 30-day time limit, and then the next step is spending thousands. There's no in between, so you've literally got 30 days to. So
Yeah.
having open source or having tools which, even if they're not the tools that you're going to go into production with, at least tools that you can demonstrate with, which are not going to expire in 30 days. Things like
Totally.
that are important.
Totally. Yeah. And as as Microsoft and by experience, I witnessed the fact that we thought it was a good example, a good sample, but then realized that, hey, you know what? After like you were saying, 30 days, your POC will not work anymore. But the problem is that to analyze, data in the long run and extract actual insights, for example, for the predictive maintenance kind of scenario I just described before, well, you need more than 30 days of data. And so your proof of concept needs to be long lasting. And so this is just one of the examples, but thinking about how can a developer and engineer understand the value for themselves for technology so that they even consider it, going fast into proof of concept and from proof of concept to my own proof of concept, it's critical. And because otherwise you never translate to an actual implementation or solution. And that's one thing that we've been talking a lot about in the last few years. The amount of IoT project that failed at proof of concept, that was because there was no easy way to demonstrate the value of IoT in these scenarios. Not because technology was not working, but because there was no way for developers to understand how to go from that blinky LED to something that makes sense for my solution. Even if I have a sense that this can help, but I cannot demonstrate that to my execs and tell them to invest for the next 6 months in that project, in that technology, because I cannot demonstrate to them the value.
Yes, there are not that many visionary execs that actually can see the small proof of concept that actually can become pilot, and then this can go to production. And these are the two big dead valleys between POC on my desk, taking it now to the where action is, like pilot, and running it, understanding how it's going to behave in the real environment, and then signing in someone to actually productize it, support it, and run it for 20 years.
And I would actually put a little caveat to what you just say, because there are many execs that have the vision, that know that this will work. But as execs, well, some of them don't, let's be honest. But
been there, done that.
And they have other skills. If they're there, they have other skills, right?
Yes.
But a lot of them who do see, they have the vision, they understand it can help them, but they cannot justify making an investment if they don't have proof. It's called proof of concept for a reason.
Yes.
You need to demonstrate the value. And if you don't demonstrate the value, the exec will not make the investment, even if they are strong believers, because they have a business to run. And they cannot afford to take a risk that is not demonstrated will work, right? There's still a part of a hunch or like risk taking, but you cannot take a huge risk on something that is core to your business and stopping producing and selling, and or developing under the pretext that you have a vision and this revolutionary technology will help you, right? So, yeah, that's definitely my perspective there.
I mean, you have really broad experience. So how actually you manage to keep yourself up to date with all these changes, all the trends in so many different fields, like industrial and commercial?
It's I don't know if I'm not up to date. Like let's be clear, it's so broad and vast that there's something that I know the gist of it, others that I've been diving in. One thing that I've been doing is keeping my hands dirty, as in, you want to present a demo at an event, do it yourself. Like, why would I go to? I go to an engineer and say, hey, your feature, can you show me how it works? Yes. Can you show me the piece of code? But then I will take the code and I will work it myself, and I would understand what it does. I never demoed something that I didn't understand how it was working. And that's because that's something, and yet I didn't create all the code for all the demos, that's for sure. But I would always understand what it is about, how it works. And actually, for lots of the demos that we were working on, I provided feedback to my teams, telling them, okay, that's a sample you have out there. That's the Hello World sample for your feature. I recommend you change it to do this, and that, because right now you're just showcasing your feature, you're not demonstrating any value. And by understanding how the things was working and adding on top this notion of value added, how does it fit into a context? Is it going to help an engineer in that domain, right, or not? By creating the storytelling around the demo, you have to deliver a value right at the end. And so you go back to the sample, and you're just like, okay, your sample doesn't work as a demo because it doesn't have the storytelling, it doesn't have the objective of solving a problem and adding value. And so I fed them back with that feedback, and we started changing some of our samples to be more driven towards a scenario, an actual scenario, and presenting things not as use like step A, connect that, step B, blink the LED, done. It was like, hey, imagine you are in that scenario and you want to implement that. So here's how you do that. And so that's something that's, keeping your hands dirty, thinking about the big picture, not just understanding the piece of code and the feature and what it does, but understanding how it's going to be used, in what context, that enriches your perspective on the technology itself. And that's something that you cannot do it all, understand everything, but having at the same time that in-depth plus big picture perspective, to me, is the way you stay in touch with reality. You stay on top of what's happening and the evolutions. The other one is luck. Being in that position where I was given the chance and the freedom to pick on the topics for the IoT show, the blogs, and so on. Well, people were submitting to be on the show. their topic. And so it would take time to work with them, prepare that episode, talk about what is it that you want to talk about, right? So it's a feature, great. Who does it help? What are the key takeaways? Where do you want them to go after that? And just having that conversation helped me understand their technology. Then looking at their demo, how they're implementing it, helped me understand what it's made of. And so that's a good way. The other one is like reading about tech. I'm excited about that. So spend more news about like reading news and watching videos about tech, and try to double click on them, understand what's going on, play around when I can, when I have time. With like we're talking about 3 teenagers. I don't have much time, so I do that during my work time, right? Because that's part of my work. So I found a job that allows me to geek during my time I'm paid for, and that's what allowed me to stay on top of technology. And sometimes appearances can be a bit abusing, I would say, but I do understand a lot, I do know a lot, but I don't know everything.
Yes.
And what I always try to do is not talk about things I don't know. And so my questions very often on the IoT show are genuine. It's like, wait a second, how do you do that? I don't understand. And some of these questions were not prepared. We do have a framework for these IoT show where we think about the flow to make it interesting, the 3 takeaways, as we were saying. But sometimes, like during the conversation, it's just like, oh, wait a second, that I didn't get. And I was like putting myself in the shoes of the viewers, but also in my own shoes. Like, sorry, dude, I don't understand what you just said here. Can you go back a second and tell me that again? And then I always try to translate it into my own words. It's not just to make people understand, it's to clarify that in my own mind, my own brain. I formulate differently, or I present things in a way that I understand better. And it happens that most people, like, I might have a very common brain, because most people work like that. When you formulate things in a simple way, they understand the technology better. So that's the way I process things. But yeah, so that's the way I'm staying on top of things. And I can tell you, I'm not on top of everything. I know more than my teenagers, and I think that's the way.
True.
I think devising demos, like you just mentioned, that is a great way, not just to understand the technology, but also to understand the limits of it. So, figuring out what, like you mentioned, what things need to change so you can go back to developers. But for these demos, what are your favorite programming languages? I'm just curious what you use.
Good question. So I've been using a lot through my career of these languages. Did I ever become an expert on any of them? I don't know. I'm not sure. But I do believe that, well, if you're a hardcore, dev engineer, and one way of making your role, your position even more important and valuable is to really know a language really well, right? You know it in and out, and you're able to optimize your code and help the others and use all the tricks and features that language has to offer. But if you approach that more from the perspective of the dev tool is the developer language is a tool, it's something that will serve a purpose. I think there are many languages out there that are designed for many different usage, different scenarios, different contexts. I would not want to use HTML5 and JavaScript to build an embedded real-time applications, because it's not a language that's been designed for this kind of application. So it will not be a good one for that. And yes, we hear about WebAssembly and things like that for embedded. Well, for certain scenarios, yes, it will work and will be very efficient, but for certain scenarios of that domain only. And so I wouldn't say I have a favorite language. I started my development life using assembly and C++. That was my background as an embedded real-time developer. I always thought that being as close as possible to the OS and to the resources, understanding what is a memory allocation,
Right.
when you deallocate the memory yourself without depending on a garbage collector, like a more advanced language, I always thought it was the way, right? When I came to learn more about these other languages, this higher level was a full framework and garbage collection and a bunch of things like that. I was like, oh, I understand all the hype around that. There's so much less work to do. And then you can focus on other things, which is a UI, which is a functionality, a connectivity, and you rely on a framework, you rely on a middleware to do a bunch of things that you were doing yourself using these lower level languages. There's also something to say about, more recent languages that have been designed with more recent knowledge and understanding and more powerful hardware and technologies. A good example is Rust. Rust brings lots of great features that will certainly lead Rust to supersede C and C++ on many embedded scenarios. For good reasons, because of the security that is out of the box and the syntax that is simpler, opening up embedded development to a broader range of developers. But there's one thing, though, that I believe, whichever language you're using, you should never, ever believe that you are infinite resources. That's my embedded developer, background. Never believe you have infinite resources. Understand what's happening under the hoods behind the framework. Like the good example of that, and this classic example, garbage collection on a .NET framework. Great, fantastic tool. You don't have to think about deallocating memory. As a matter of fact, I'm pretty sure lots of .NET developers, especially younger ones, have no clue what a virtual memory versus physical memory in an operating system is about, right? And you end up with things that are, not working as expected because of that over-reliance on the middlewares with no understanding of what's under. So yes, you can drive a car without understanding what the transmission is doing, what the engine is about. You can drive a car very efficiently without that. You will not be a Formula One driver if you don't understand how your engine works, right?
Okay.
So you can be a without diminishing that, you can be an Uber driver without understanding a single thing and never have opened the trunk of your car. And so at the end of the day, a language is something that you will want to know really well. At the end of the day, it's freaking bits underneath, right? Do you have to understand all the way down to assembly? I don't know. Do people know that at the end of the day, it's machine language that all the compilers are generating, and that at the end of the day, it's freaking binary that still runs on the machine? I think it's important people realize that it's we are bringing new languages in the form of, at the end of the day, frameworks or compilers that enrich the experience of the developer, gives more powerful tool. But at the end of the day, you need to understand what's going on underneath to be a good developer, whichever language you're using. And so consider language as a muscle, work the muscle. You cannot work all the muscles at the same time. You cannot be an expert on everything, but you can definitely be fit and run fast and develop the muscles you want to develop. So that's the way I'm approaching developer languages.
Your story reminds me of I worked with C originally, and that was back when smart pointer libraries had trouble with them. They were a bit problematic sometimes, and the amount of memory leaks dealing with those, and crashes looking at core files, and then having to disassemble the core file, having to see, even doing crazy things like trying to put special key values around variables to see if memory gets trampled. So all
Like
that problem goes away if
fond
use other
memories.
languages.
Fond memories, but obviously these days we old people, younger developers, look at us just like, why would you do that? And they're right. I mean, at the end of the day, what you want to do is focus on the value add on top, right? And so there is value in being able to do this kind of things. Should everyone be able to do that? No, you don't need that. And so there's something to say as well about no code, low code. We reached a point where we now have an interface layer that allows you to build logic that can be distributed without having to write a freaking line of code, just using your logic. And not even talking about the co-pilots in your dev tools or ChatGPT that can generate a piece of code that just works. That will help developers grandly a lot. But now we are at a point where we enriched and multiply the options at all levels to build applications. And that's why I'm not saying developing applications. You can build applications using code, but also you can go all the way up the stack and leveraging a graphical user interface to build an application. And other developers will develop the underlying stacks you will just use. There will be development framework. There will be more advanced types of middlewares and frameworks. But now you can go and add value at that level and create a workflow rather than create code. But the logic is still the same. If this happened, do that, right? It's whether in parallel or not. And you will start having problems in these flow development tools that we used to face in the past, like the multi-threading problems of having multiple tasks in parallel. Now you transfer that into a no-code environment where you start workflows, and now you say, I'm going to start 2 workflows in parallel based on the same alert on the temperature value to create a ticket and send maintenance, as well as create like something else, right? Which event to write first? Which action needs to happen first? Doesn't look like, is there going to be a deadlock situation in your flow? You see where I'm getting at here?
Yeah.
You're going to start having similar problems to the one we're solving in code in an environment that is higher level. So I'm not saying you're going to have all the same problems. Some smart people would have thought about them because we've solved them already in many ways. But these higher level way of developing or building applications will have their own challenges and problem, and the same level of expertise will be required for someone to be building things there. But it's open to more people, so that's great. More people can build apps, and you can focus, and you're closer to the value, the business value the application will provide when you're on that side of the spectrum. And then you still need to have someone creating the code for that device on the other end that is providing that temperature alert, by the way. So it's all good in a better world, right? So we're going to have more and more people working on software at different levels, and using the language or the programming interface that they prefer, and focusing on their needs, right? Do they need to solve an actual business problem and create a workflow, or do they need to make sure that connectivity to the internet is super secure for that device to not be a problem for the rest of the application?
Sometimes I think that Blinky should be replaced with, in the modern age, it should be replaced with temperature, because it's so important, right? As a quantity to measure, industrial processes in the home, physics, learning. It's way more important.
Please do it in Celsius, not in Fahrenheit, right?
And did you experiment it with prompt engineering? Obviously, something that all the cool kids are doing today. They just go and they craft specific prompt, and then Codex or ChatGPT actually spitting out everything.
I've been playing around with it. I've been talking a lot in the last few weeks with developers and asking them, hey, like, what do you think? Are you going to use that or not?
Yes.
And it's mixed feedback, actually. And the one general impression is that everyone agrees on the fact that it's going to accelerate changes in the way we're doing software development. Like, it's going to change a lot of things in many domains in the world of software development. It definitely was already starting to happen. I mean, like, Copilot in VS Code has been there for some time already, months, not years. But still, it arrived and wowed lots of people. Now with this new kind, which very similar type of intelligence or artificial intelligence, you have new tools that you have to add. You're going to use in your arsenal. New tools, and developers will get more equipped and richer, and that's going to definitely evolve the way we're doing development. That's for sure. One other aspect, especially for those who are familiar with open source and open source licenses, is the complexity it adds at this point in time in terms of using open source code, especially for big corporations. Like, how are you gonna are you allowing your engineers to integrate code that's been generated or coming from some AI that does not give you any reference on where that piece of code is coming from? Because these AIs are building code based on, things they found online or in the resources you gave them, right? And so probably that piece of code they're giving you has been written by someone. Maybe there's a license to use it, but you don't know, right? And so there's a big, huge problem that will be solved. I'm not worried about that, but that makes professionals, react and say, "Oh, wait a second, there's something we need to pay attention to here." Problem will be solved, but it's not going to be instantly auto-generating code everywhere because you will want to make sure you are allowed to use that code, because there are rules around open source that everyone needs to follow. Otherwise, it would just fall apart. But yes, I think I triple clicked here in that rabbit hole, but the idea was really about how do I think technology and this kind of things will change the way we're developing, the way we're building. It will change a lot, but we need to do that responsibly, and I think people are asking the right question already.
We also have special kind of themes for the different months, and March is the month of Kubernetes on our show. And obviously, you see all these jokes about if the question is IoT, the answer is Kubernetes. So, what's your point of view of the whole Kubernetes orchestration, edge computing, all these new trends?
So that to me goes exactly in the context of that pendulum of the world of IoT, since its inception, or when the buzzword was created. Everything was about devices, right? And making devices smart. And suddenly we're saying, well, the devices are connected, so that means that they will just send the data to the cloud for the cloud to deal with it, right? Because devices cannot deal with data; they don't have the compute or whatnot, right? And then technology evolves, compute power grows at the edge, and there are plenty of scenarios where you cannot afford to send all the data to the cloud for the cloud to do something. So pendulum is coming back and saying, wait a second, we need to do compute at the edge, we need to have the data staying there, we need to have more capacity down there. And the other thing is the reality of IoT and operations world, and whatever the name is that it's not about a sole device talking to a cloud service and that's it. There is so many pieces in between of different sizes in that connectivity, in the infrastructures, that you can think of starting leveraging what's in between. Right? If like any scenario of a device connected, it goes through a gateway, whether it's a cellular antenna gateway, whether it's a Wi-Fi gateway, whether it's a LoRa gateway. Every single device that connects, even wired, right? If you go through BACnet, Modbus, whatever, you end up on a server that is on premises that then gives the data up to a service in the cloud or somewhere else. And so the evolution is to say, hey, we do have resources down there to store, to compute. Maybe we can keep the data on premises for privacy reasons, for security reasons, for whatever, for saving money, because connectivity has a cost. And so these technologies have been enriched, with the idea of like, hey, we can leverage them a bit more. And Kubernetes is very interesting because it gives you a control plane that is unified for how you deploy pieces of software in the form of containers. Honestly, the implementation doesn't really matter. What matters is that the industry is gathering around a way of defining containers, deploying and managing them. And so the industry is adopting Kubernetes and containers as a way to distribute your application, put pieces of intelligence here and there. It also has feature for resiliency, which is super interesting. When you have a critical system that you want it to stay alive on premises, factory floor is a good example, but you have like plenty of other scenarios where you want to have resiliency. You want to make sure that if you have a piece of software that detects an anomaly on the conveyor belt, that it still works if my server goes down physically because it's a harsh environment, that's another one can take over and can now provide a resiliency and a trust level in that infrastructure and system that is high enough so that I can automate my factory floor. And so Kubernetes is in terms of technology, it's not rocket science, but the fact that the industry is gathering around, to me, is super important. It also relies on the fact that, as I was saying, that pendulum has been coming back with people realizing that we can do more than we thought on premises by being smart and by having the ability through that nascent technology, not nascent anymore, but that almost established technology, to securely distribute your intelligence and run pieces of software that have been developed once in different places, independently of what the host is. It's kind of key here, because maybe you will have to deploy piece of your software on a gateway that is pre-existing that happens to be running, a Linux distribution.
Yes.
And then you need to run another piece on something that is running a Windows OS. And you want to abstract that underlying layer, keeping one pane of glass for distributing, managing, monitoring, and operating that solution. This is not new. Distributed applications is something that's been around for a long time, especially in the world of robotics. Like almost like how long ago? I'm trying to do the math. 15 years ago, Microsoft Robotics Studio was a great example. Was a decentralized service that would allow distributing intelligence, and then you would at the node level have a way to exploit or use the hardware with a level of abstraction. It will allow to have one way of coding running on different type of hardware based on the framework. And so distribution of your intelligence is not new. The scale at which it's going to operate is changing.
Yes.
Kubernetes will definitely bring solutions, but there's one thing to say, though, is that it requires a bunch of resources. So Kubernetes requires a Linux or Windows machine that has sufficient, RAM and CPU and so on. We will get to a point where containers can be run on microcontrollers, but we're not there yet. And so there is time for to think about how this app model of containers and Kubernetes will translate or extend to the world of CPUs. But I'm a strong believer that bringing this technology to come from the cloud, microservices notion was born in the cloud because of infinite resources and huge servers, to realize that, hey, how if we make that model, that app model at the end of the day, available on premises? For now, it's on clusters, on Kubernetes clusters, that, yes, you can do a clusters with a series of Raspberry Pis, but to all the embedded purists around here, we all know that a Pi is just a small PC or a small server, right? It's not an embedded device per se.
Exactly.
And so at the end of the day, the millions or billions of devices and sensors we always talk about, they're not Raspberry Pis. They are the leaf devices behind the Raspberry Pis. But here is the interesting thing. Now, the Pis level and above, if they can be managed for applications to be seamlessly deployed to them from a centralized place, which is the cloud, now you have a way to bring that application as close as possible to the sensors, to where the data is. You can process the data down there. You can develop autonomy as well for systems and optimize them all the way down there without having to do a full cycle of like sending message to the cloud, having analytics in the cloud, and getting down to the devices for a response, which is that notion of edge compute that is essential to the growth of IoT in general and whatever other technologies. So this is, to me, Kubernetes, because the industry is rallying around it, because it's a really well-designed technology, and because there are so many actors adopting it, is definitely great news for the industry. The other trend that I'm seeing is the notion of digital twins, the notion of making sense of the data and putting the data in the context of the environment in a virtual way, reflecting the actual physical way. And I'm yet to see exactly how The implementation technologies like Kubernetes will tie into that model, but that's going to be super interesting to look. And that's something I'm really interested in and investigating and looking into, because all these technologies are getting together. I think we mentioned that earlier on. It's all about having different types of technologies being put together to implement solutions, and each deliver their own value. And I do believe that there's something to say about distributions of applications, entities that are in the form of clusters and pods on these clusters. There is something that, there's an analogy was the twins, the digital twins. Will a digital
Yes.
twin be representing a cluster with all the pods on them? Very likely. I mean, at the end of the day. And then in your digital twin in the cloud, you will represent that cluster and all the leaf devices with their relationship in a graph that you will be able to query. And now all of that makes sense, because it's all managed in a single place with a single pane of glass. You go across clouds, across hybrid infrastructure, edge and cloud, with one language, with one infrastructure, or one set of commands, and so on. And so it's like, it's thrilling. I mean, and we're talking about something that is being implemented now. The adoption of Kubernetes as the implementation of these containers at the edge in an industry standard way is it's going to accelerate things dramatically. I'm convinced. And so yeah, that's what I had to say about Kubernetes.
Okay, so since you're really passionate around digital twins, and I mean, obviously we haven't discussed it on the foreshow, but what do you think about the industrial metaverse? I mean, since we went into the digital twin,
yet another fancy word that I hate and like at the same time. The industrial metaverse, it's just a fancy way of talking about digital transformation. That's the way we're talking about it earlier on, right? And we engineer, tend to like these buzzwords, and especially our business friends, because it's easier to use a buzzword than really understand what the technology is about. But I'm a strong believer that creating digital models of actual real environment and tying them together, thanks to IoT, by the way, and other technologies. But you are able to do two main things. One is simulating. You can put an infrastructure at test without putting it at test. You can improve your solution by putting your digital twin, the digital version of your infrastructure or environment at test in very harsh environment, putting it to the extreme without the risk to arming anyone or to destroy equipment or whatnot. Simulation to me is number one in terms of timing of interest for digital twins in the world of the industry. And so when we say industrial metaverse, to me, it's about this combination of technologies that will help the industry go from where it is today to what is going to be tomorrow, which is something that is more automated, that is safer, that is more efficient, thanks to the simulation to start with. And secondly, thanks to the ability to provide the data and the insights from the environment, the actual data, to operators in a way that is usable and understandable for them, with a very powerful graph engine that will allow to do some very sophisticated queries really rapidly. An example of that is the complexity today to implement an actual predictive maintenance scenario in factory floors. Because today, when you want to implement this kind of scenarios where you detect that a conveyor belt, once again, is about to fail, to go all the way down to triggering the right workflow for the right team or person to go fix that at the right time, implies having not just the data from the device, but also the data sheet from this specific equipment the sensor is on, which very often is coming from different sources, then to tie that into the right set of models to analyze the problem, detect which parts might be malfunctioning and so on, and then to tie that into your business apps and any kind of ERP, CRM, whatever, and then also into your own internal systems, which engineer, which person is the right one for solving that, because they're located here, they are on duty and not on vacation, because they have a round already planned and they can do a stop for an hour there, and make sense of all that data in a context, which is the freaking failure of that conveyor belt, and the fact that this customer is not going to be happy, and that I can go that time in the day with that person and so on. So all of that, you see, just me describing that, you already have all these knots in your brain. Digital twins and the building of a industrial metaverse will help address these problems in a more efficient, and faster way. And that's all it is about. More efficient to make more money, right? And to produce more at a higher quality. There are side effects that I really love, like protecting the environment, saving energy, and so on, which is great. Unfortunately, today there are side effects, but they will grow in meaning and importance. But at the end of the day, with that said aside, industrial metaverse to me is not just the buzzword. It is the fact that we have a buzzword means that we have technology ready to go, to be assembled and to be used to implement these very complex scenarios. And so my strong belief is that, yes, it's a buzzword, but there's a reality behind it that all of us will live with. And, like IoT a few years ago, as it's so like tiny technology in its corner, has developed and grown to be more mature and mainstream these days. Industrial metaverse is a buzzword. Will it change to another buzzword in a few months or days, or I don't know. I have no clue. I kind of like the metaverse term. It's interesting for millennials and Gen Z, and so that's something that I would love for us to keep. But to me, it's a reality. It's not just a buzzword. It's a set of technologies that are to be implemented and are ready to go.
Yeah, and not just reality, but inevitable. It seems like now it's hard to imagine a world where if we have IoT, digital twins is inevitable and is happening. There's nothing else that you could do. You'd have to have that to be able to handle all of that volume of data. And the technologies of metaverse are inevitable.
Yes,
it's going to have to happen, whatever it's called.
So you've met really a lot of interesting people through this. Again, we don't want to say again the years of your professional career. So we've been thinking like, which are the really most interesting organizations at Microsoft that you have worked with, and are there any startups, like really interesting startups that got your attention?
Yeah, there are many, and I will not mention names because I don't want to make any jealous. But I think that the ones I'm getting the most excited about are the ones who are able to identify and go fill in a gap in the industry, and there are so many gaps. I mean, like we're not covering, we're not today covering even like a small portion of the possible there. And so just to give you an example to be clear here, is that company that had the idea, fantastic idea of tying the world of LoRaWAN devices and sensor, which is about long range, low power devices and sensors that are connected through that network, to tie this world with the world of Power Apps, which is about streamlining business decisions and workflows, development, building. And these are at the two extreme. One is like, hey, the little sensor which is around your dog's collar that talks, at the very low power, to an antenna to give you the location of that dog. Or I'm just like having some stupid scenarios in mind here, but tying that world that is about, hey, I have the sensor, I own it, just scan the sensor, to, hey, when that sensor triggers that information, I'm going to start that workflow in Power Apps. And taking care of everything that is in between for you as a customer. So that is genius, because that is a specific scenario of putting this and this together, and there is an actual need for that, simplifying all the stacks in between. And their solution is just doing LoRa. right? It's not doing all the rest of the possible protocols for communicating like Zigbee, Bluetooth, whatever. They're doing LoRa, but they're doing it well. And they're giving to their customers a path for all that data from these LoRa sensors to feed Power Apps. And so, and they're just hosted on the cloud as a service. So you don't have, you just have to deploy that and use it. So it's pretty straightforward. But I think this kind of companies that are able to identify this use case, this like, Goldilocks of a scenario, and implement it correctly, focusing on that solution, are the ones, are definitely the ones that are the most excited about. Another company that really loved engaging with, we did a night show episode with them recently, is one that identified, we talked about the industrial metaverse. Industrial metaverse is something very abstract. They identified the fact that we could make it real by building real life replicas of an environment in the form of toy bricks,
It's
right?
the best.
Plastic toy bricks,
Yeah.
and to showcase the value of the technology, like digital twins and IoT platforms and sensors, for in that case of the discussion we had, for a smart city scenario. You cannot bring a smart city into a show hall at a big event, right? And showing something which is just a 3D rendering is not really physical or tangible. It's virtual. And so they are creating demos that are based on these plastic toy bricks, and they are implementing all the technology, the sensors, connectivity to a cloud service, a digital twin that is representing that smart city and all the various parts of it. And they're explaining the value of the services through this kind of demonstrations. And once again, talking about POCs, going to an actual implementation, someone can take their demos, put the sensor on an actual building, in a room, to measure temperature and presence, the same way it's been done on that little toy brick replica.
Interesting.
It will work the same way.
Yeah.
And so they identify that as certainly a way for them to play around with these toy bricks as adults, which we'll all want to, and being paid for that, but also as the simple but magic way of making things more tangible, to demonstrate the value of a very intangible and virtual technology, which is that new buzzword of industrial metaverse. And so this kind of innovation, creativity, and ability to go fill in gaps and develop something there, that's the kind of things I'm really excited about, and I really believe is contributing to making that world interesting and motivating, and so for all of us, all good.
That's a really cool use case. I mean, we geeked out a lot today.
Yes, we did.
Yes, I really hope you didn't have any plans for your day, because obviously we went way over the time that we've been thinking at the beginning, but I just can't stop. I mean,
yeah, it's fascinating listening to this.
It is for me too. Like I told you, I can't stop speaking. Sorry for
that. But yeah, we want to give you some time during the day, so you can see the family, and maybe you can do something else.
Yes. Well, right now, just to tell you the truth, I'm alone at home. I need to go walk the dog. The kids are at school. My wife is at work. I have the house for myself. So hence, like we were not disturbed during that full hour and a half or something. And but it was a great pleasure. Thanks for having me. Milko Shabazz, that was a really good time. I really enjoy and appreciate this kind of conversation, as you know.
Thanks.
No, it's been brilliant listening to you. Thank you.
You helped us a lot, actually, with a lot of ideas that we already have implemented, and we're going to continue implementing. And I guess a lot of our listeners are actually going to implement in their daily business. I mean, how they can find you, how they can reach out if they want to know more, if they want to.
Yeah, well, I'm on LinkedIn. Just say hi on LinkedIn, follow. I'm on Twitter as well. You can see my Twitter handle down there. I have a link to Mastodon, but I'm using Twitter most of the time. I have my own opinion there. Nothing against anyone.
Okay.
But I'm on Twitter, Mastodon, LinkedIn. Find me there. And I don't know if I'm going to blog again or whatnot, but maybe you'll see me in the communities. That's for sure. So you find me around.
We can't wait to see also TikTok channel from you, like very short videos. This is how you do temperature sensing. This is how you do.
Yeah, I don't know if I can do short. I will try. Maybe the 1.5 I can try and build a series of TikTok videos that will explain all of that. So, like, that's a good idea, actually. You had a good questions today.
Thanks again, and
Thank you.
thanks to all our listeners. I mean, I really hope you have enjoyed the hour and a half with us, and we'll be having multiple shows over the month. So we'll be back with more topics. I don't know if we can find so interesting guests as Olivier, but we'll do our best. And thanks again, everyone, and see you next time.
Bye.
Thanks,
Bye-bye.
everyone. Thanks, Olivier. Bye.